This is question 24 from section B of the 2018 PBSAA. So in this question, we're given a cuboid that has sides of length x, root 2x and 2x, where x is some unknown positive number. And we're also told that the cuboid's volume is twice its surface area. And then, as you've probably guessed, we're asked to find x. So we've got this cuboid, and the property we're given describes the volume and surface area in a relationship between them. And we've got these terms x, which you can see on the cuboid here, corresponding to the length, width, breadth, depth, etc. And so it'd be a logical choice, I think, to try and get the volume and surface area in terms of x. And because if we can get them in that algebraic form, then we might be able to get something out of this. So let's work at the volume first. So the volume, V, is equal to x times root 2x times 2x, i.e. just a product of all three dimension lengths. And that's 2 root 2x cubed, because we get 2 here, the root 2 here, and the x's. We've got 3 of them, products together. So that's quite nice. The surface area is a bit more awkward. So we've got surface area is equal to 2 lots of this area. So essentially x times root 2x in the red. So that comes from here. And we're taking 2 lots of it because we'll have 2 copies of each rectangle we can consider. Plus 2 lots of this, the blue, which is 2x times x. And then plus 2 lots of the remaining front rectangle here, 2x times root 2x. So if we add all of this up and expand it out, well, we can collect these x squared terms, because you can see we're going to get an x squared term for each one of these terms. So 2 lots of root 2 plus 2 root 2 x squared. But then expanding this out, we get to 4 plus 6 root 2 x squared. So we've got relatively nice forms for the volume and the surface area in terms of x. So we've got our expression for volume and surface area, and now it's simply a question of algebra, this. Because what we have to do is bring in this fact we're given. The cuboid's volume is twice its surface area, or to put it algebraically, V equals 2s. But then if we shove in our V here and our S here, we've just got an equation in x. And if we solve that, we'll find the value of x like we had to. So just subbing these in, we get here. And this initially looks pretty awful. It's a cubic. Well, let's try and cancel what we can. So we can get rid of these 2's, right? Which is good. Now, the next thing we'd like to do is say, we'll divide both sides through by x squared. But what if x squared is 0? So x is 0. Well, that's not a worry, because x is a length, and lengths can't be 0, they have to be positive. And so we can happily divide through by x squared. So, reduces to this. Once we do that, root 2 times x is equal to 4 plus 6 root 2. Divide through by root 2, and we do get an expression for x equal to something. We're not quite done, because it's a bit of an ugly form. We've got an irrational denominator. I'm not a big fan of that. How can we get rid of that? Well, if we times through by root 2 over root 2, that'll do it, because it'll take the denominator to 2. And the numerator, well, we get 4 times root 2 plus 6 times root 2 times root 2, or 6 times 2, which is 12. So we get this. But 2 cancels the factor of these top 2, which is good. So we get x equals 6 plus 2 root 2. And that is reassuring, because that's option B on the multiple choice. And so our answer is B.